All right. So that, everything that I told you was what we did for FVP 1.0. And that was a very proud moment of ours because, people actually do the easy things first and then leave the hard things to a roadmap. When I spoke to you last year, I didn't show you a roadmap. And actually, I'm not going to do it this year as well because we just do the hard things.
Because he doesn't trust us.
Well, not just that,
but
you
Howard.
That's because he knows me.
It is better to just implement the roadmap rather than talking about a roadmap. So that's what we do. But since we did 1.0, which had all the other things that I talked about, it was a product that was really complete. It solved the read problem, the write problem. It gave you scale out storage in the most seamless manner. You could put any workload on top of it, databases, Exchange, SharePoint, VDI, it doesn't matter because it doesn't just solve the read problem or it doesn't just solve the write problem. It doesn't require a virtual appliance. So you treat this as an infrastructure level investment, just like how you install a hypervisor, you install this thing and move on with your life. That was our main goal. And so far it's been working out very well. Since then, we released an update to our product. It's called FVP 1.5. We made some changes. The first change we made was we support VMware's newest UI. It's vSphere Web Client. It's a different way of doing things, slightly slower. But
beautiful.
Exactly, yeah. I've been told
it's pretty but
beautiful.
useless, yes.
But and that's one thing we can't accelerate. We are still working on it. But, we'll get there. But anyway, the cute thing about the web client is that when we first released 1.0, FVP 1.0, we actually put in a lot of thought about the operations part of storage acceleration. Is that what is it that an administrator actually wants to see? And so we actually provided a lot of data on a per virtual machine basis as to what the virtual machine is trying to do. How much of its IOPS is coming from the flash layer, how much is coming from the SAN, how much is coming from the network flash, how much of it is read, how much of it is write. And so literally people have blogged about it, is that they install FVP, it makes things faster, they move on with their lives, and the more now they are more interested in the operations aspect, is that they are now looking at a level of detail about their workloads that they never had access to. And so we made it better in 1.5, is we actually took that platform and we ported it as a native plugin to vSphere Web Client. And so now it's right there. And the other thing I'm really proud of as a company, especially since we are solving a hardcore systems problem, is that we take care of the little things. And, when we shipped this thing, we said, well, now we support vSphere Web Client, so go for it. And the most amount of positive feedback that we received was about this screen on the right. And this, by the way, is from Chris Wall's site because he was the first guy to break the 1.5 news. This screen.
He's not even here. He's getting FaceTime.
Yeah, and half the internet thinks I'm him. So,
And he's not even sitting next to Howard.
Well, here's Chris right here.
yeah. Hi, I'm Chris Wall.
Hey, Chris.
Word.
He's not even tweeting on the live stream.
No.
He's at a V-Mug.
We'll fix that as we go on. So anyway, so we did this, and the most amount of positive feedback we got was when you first log into the web client and you click on flash clusters, we are a HTML5 JavaScript based system because we believe in the future. And so we plugged in that system into a Flex based system. And so you need to, when you do HTTPS, whatever, long story, you need to, the browser throws a really crazy screen saying, oh, well, untrusted site, and some gobbledygook depending on the version of the browser you're using. And it just doesn't make any sense. It's very ugly. And so instead of letting the browser throw that, we made this simple screen which just says that you are going to need to add a security exception. And you click on the button and you say add exception. And people went wild about it. This was the most interesting thing to people. And I love it because, we thought about this. We thought about the ugliness of that crap page that shows up when you don't do that. And we fixed it and people loved it. And so I'm very proud of the fact that, we not only take care of the systems problem, which is a hard problem in itself, but we love to spend time on actually making this a very magical user experience for the end user. Some of this reminds me of my car. My first car was a Beamer, and this was like 1 week at VMware.
Your first car was a BMW?
Yeah, and I'd only spent 1 week at VMware. This was like 2002, and obviously I was young and restless. I thought a Beamer cost much less. But anyway, the great thing about a Beamer.
Drive a '57 Chevy with 3 bald tires, and get some real experience.
3 bald tires.
As Rob plays the world's smallest violin. You probably never even walked to school uphill both ways.
In the snow.
Well,
definitely not in the snow.
Not in the snow, but I did bike to school in 135 degrees, so
Okay.
Okay, he wins.
That's the same temperature that another storage vendor tests their gear at.
Or
explains the color of my
Duncan
skin.
access to get back on track.
Okay.
Whatever.
We should do what Duncan says.
All right, so it is the little things that count, and now since Howard trumped my Beamer thing with his whatever 57 piece of junk, I'm not going to tell you the story. No.
Ah.
Oh
To be
no,
fair,
I
Howard's that
ruined
much
it.
older than you, though.
Yeah. Anyway, so moving on, the other thing we did with 1.5 is we worked with VMware to get this whole thing vetted out through their qualification process. And so happy to report that now we are the only vendor who actually inserts ridiculously crazy complicated amount of stuff inside the hypervisor, and we made sure that this is kosher with VMware. This is something again that we are very proud of. Is it's one thing to actually do college projects, but we are selling to the enterprises, so we take this not lightly. We are using public APIs that VMware has. They don't have too many, but whatever they have, we are able to use, and we are able to get it blessed by VMware. So that's what came out with 1.5.2 is a signed WIB, which you can just use as part of WAM, and it's a clear support agreement between VMware and us as to what happens when things go south. The other thing we did was, and this is now FVP starting to grow up. It's one thing to do caching, but then you have to worry about data center design. Is as soon as you do write acceleration, you are actually sending a lot of traffic over the network. And for ease of use, what we did was, out of the box, the product just latches on to your vMotion network. And so there's absolutely no networking configuration to do for you out of the box. But if you so choose, if you're going to run a ton of VMs in write-back mode, etc., then you would actually want to probably design a network, a data network, which you didn't have earlier. Because, unlike a vMotion network, which is used only now, every now and then, this one is going to be used all the time, and this is carrying your storage traffic. So this is not something to be taken lightly. And so we gave our users the ability to actually set up a special network that could be dedicated to FVP traffic, and then choose it. And when it comes to choosing networks, the problem is you have to do it on a per node basis. And so the UI we did was you could set up a network, and then you could choose that particular network on a cluster-wide basis, and that's it. One click and you're done. You're on a different network. Or you could choose different networks on different servers, and then FVP will figure out how to talk using those different network interfaces. So those are the choices you have. But these are now we are starting to get into not just doing the product, but actually trying to integrate that product into what is apparently the software-defined data center. We are not an island, so we got to do things like this to actually make sure that the whole story works out. It works out in totality. And then we did one more thing, which we never talked about, and this is the first time we are going to talk about. I'm very excited about it. And so, we talked about this thing, when we released FVP 1.0, we called it the Flash Hypervisor. first one. Use the first one, please.
Yes, sir. Yes, sir.
But anyway, so we call this product the Flash Hypervisor. Well, what does it mean? You know, we said that it is a system that virtualizes Flash devices. It organizes your Flash devices and your networks into what looks like a cloud of Flash. And then we use that cloud of Flash to give you unbelievable storage performance. Well, that's fine. So we are actually removing the boundaries between your Flash devices. We are making it into a cloud, which is why we called it a Flash hypervisor. We virtualize Flash. Now the Flash that you see is not necessarily that one device. It is some collective conscience of Flash devices. And so that was our definition of Flash hypervisor. But you know, you can take it one step ahead, right? Is that you could make a Flash hypervisor which makes a physical Flash device look like something totally different, do other things to Flash devices. And so it is not now necessary that the overall I/O characteristic, the I/O performance that the Flash hypervisor gives the application has anything to do with the I/O performance of a Flash device, because we virtualized it. We can make it high, we can make it low. Well, it's very easy to make it low. Just throw a bug into the system, but it's very hard to make it high. But that's exactly what we did. Is, you know, if you think about a Flash device, and they have very different performance characteristics when you do different types of IOs. I'm sure you all know that, right? You know, you do small IOs, you do random IOs versus big IOs or sequential IOs. Absolute night and day difference in terms of how the Flash device performs. You overwrite stuff, night and day difference between what the Flash device does in terms of numbers. So what the Flash hypervisor can do for you is that it can take an application that was never designed for Flash, and then it can actually sort out that I/O to make it work better for Flash. It can change I/O sizes. It can change the orders in which IOs are done. It can do crazy things. It can, you know, change the order in which different virtual machines send IOs out to the Flash device, all to make the Flash device perform better than if you actually literally attach that Flash device to that application. So, you know, this, what I'm showing out here is a run, a virtual machine that we ran. The workload doesn't matter. That, you know, that you know, stopped our virtualization, so to speak. And I call this new feature F squared. You know, clearly an engineer came up with the name, but it is what it is, F squared. And so, you know, this run is without, you know, this technology, F squared. And what I'm showing out here is a curve, is the total number of IOPS that the application sees, and it's roughly, well, 34,800 odd IOPS. You actually turn some tricks on inside this software layer, and that same Flash device, the same application running on the same Flash device, sees 54,400 IOPS. And so nothing changed. The Flash device didn't change, but the overall performance of the application as it sees it has changed drastically.
You somehow optimize the write activity to not overwrite or something?
Exactly. So you optimize the IO streams going out to the Flash device in a way that the Flash device performs better.
Yeah.
And this is the beauty of virtualization, right? Is you can do things that are totally unknown to the application. Now you don't have to design applications to work well with Flash because it is not their problem. You know, this other intermediate layer can actually take care of that problem and can take care of the problem for N applications. That's the whole point of virtualization, right? And, you know, when vMotion was invented, a lot of people had actually, struggled with process migration. And, you know, some guy would make a kind of research paper on process migration and make it work for a process that was a web server. But, oh, by the way, it doesn't work for a process that's a database server. And so, and then virtualization comes along and it says, well, you know, I'm just going to do it here. And so it doesn't matter what you're running. It could be an FTP server. I can migrate it. And so same thing here is now it doesn't matter what application it's running. The virtualization infrastructure will make sure that it is optimized for Flash.
Does it depend on the type of Flash? Are you optimizing for particular vendors?
Good question. So the worse the Flash is, the better the difference, right? So this run is on a SSD device.
Okay.
well, I shouldn't call it worse, but you get the point. Is
Yeah.
the
Less optimized internal
less
flash
optimized
for-
flash
yeah,
devices.
you guys can support. So if you're going to do the writes out of order, I mean, doesn't that present some integrity issues and stuff like that?
No, so
that, you know?
Database
Yeah.
people are going to hate
So-
this.
I would think so. Yeah.
good point. So maybe in the just so we keep going, maybe in the private part of the session, I can give you a more detailed answer. But the answer I'll give you right now is that no, we don't screw around with write ordering.
Oh, okay,
In
'cause
other words, there is no
I thought he had
difference.
said that earlier or whatever.
There is no
reordering.
difference in the ordering
Between the two,
as the application sees it between this and that.
as
So-
the application.
Yeah, but
sees
how
it.
does it get to disk?
Now, as the infrastructure sees it,
That's
there might be a
different
difference, right?
Yeah, well,
But
yeah.
the application doesn't care.
Can this be disabled on a per VM basis?
Yeah.
This
Or is
can
this
be.
All on, all off sort of thing.
I think this can be disabled on a per VM basis. Now, this is the sad thing about writing less code than I used to in the
Yeah.
past. But yeah, if I
Okay.
recall correctly, it can be. But I will say one thing, which is, and this is one design philosophy which we stuck to very well so far, is we actually don't expose those knobs. I mean, yeah, sure, we have that automation framework that you can actually tweak the knob, but we
But
would
the
never
on off or whatever. So
on or off. Yeah,
so
But we
that I could
wouldn't-
use this. I could shut this off for database guys that actually worry about the order in which their writes happen to infrastructure.
device.
No, yeah, but the thing is, the only reason you would shut it off is to prove to the database guy that this is doing nothing, to make them worried.
Yeah, you don't know database guys. It sounds like a joke, but yeah, yeah,
They're still uncomfortable with RAID 5.
yeah, this is a big problem for
Right.
okay.
But it can be proved that nothing changes. But yeah, I see your point. There could be. So this is IOPS, but the same experiment from a latency point of view. And forget the curves. I mean, unfortunately the y-axis went out of whack between the two results. So don't worry about actually looking at the exact curve. Worry about looking at this part. And so with f squared off, when we run this workload and it gets whatever 35,000 IOPS, it gets it at a VM observed latency of 1.65 milliseconds. And we turn this technology on, the VM observed latency for that higher number of IOPS, which is 55,000, is 0.99 milliseconds. So it is not just a IOPS thing. In fact, the IOPS part is less interesting because virtual machines are not trying to get 30,000 IOPS. What they are trying to get is lower latency. And so we can make a flash device with reasonably good characteristics look even better.
So are you building a log in RAM and aggregating writes?
Well, so building a log is obvious, right? Because you have to do it for garbage collection, write amplification, etc. So this is more than that, and I'll stay hazy because obviously I don't want our competitors to also implement it. But yeah, there's a lot going on in terms of how you iron out the I/O to make it look much better to a flash device. So this was the fun part. This was the fun part of the release. Something that we never talked about, but something that we were really proud of. So that's all I have to say about 1.5. Any questions so far?
So you reorder from the application to flash, but not from the flash to disk, right?
Yeah, that's what I was just hearing as well.
No, I'm saying the application doesn't see any change.
Doesn't see any change in the order
So
it
you are-
executes
And
writes.
that is
Right.
what matters, right?
Yeah,
We can
yeah,
do
and
whatever.
Frank was just correcting
Yeah.
me
Well,
online
when we-
here that
when
this
we-
is just into the flash, not into the back-end storage.
Right,
Yeah,
but
so-
I mean
Yeah.
it matters when we start talking.
Oh, disk. I get it now. Yeah.
Yeah.
Okay. So the answer is yes. Yeah.
Okay.
Yeah.
Yeah, because it matters when we start talking about data services
Mm.
on the backing store,
Mm.
that it be seeing data
Yeah.
with write order integrity.
Yeah.
Okay.
I have a question, but if the SSD device is backed by a cache itself, like a storage array, so do you see the same kind of improvements, or there is a risk about internal optimization of the cache that brings something strange out?
All right. So we internally call this do no harm. Is that the least we want to do is to not screw up the what the flash device can do for us. And so, well, two answers to your question is that if the device is slightly more intelligent, then the gains, the difference will be less drastic, right? Which is obvious. But we will make sure that whatever we are doing on our side doesn't actually make an intelligent device perform worse than what it used to with our stuff on. So yeah, we made sure of that.
It's nice.
All right, so my favorite part. But no more questions? I think.
Snapshots and clones and all that stuff, pretty transparent to you, or?
Yes, it is very transparent. All virtual machine-based snapshots work. Whatever cloning, whatever you do to a virtual machine keeps working.
And then the storage snapshots and storage clones, they don't get affected.
Exactly. And in fact, last storage field day, we talked about how, which is you do need to actually synchronize the cache if you want that data to actually show up in your storage snapshot and so on. And last storage field day, we also talked about some automation that is available in our system to do it. Last storage field day, we also talked about the FVP allowing you to do all this live, so you don't necessarily need to, whenever you want to do it, you do it, and then transition back into the write mode once your snapshot is done.